So question 19 is another question about sequences, but like in this case, the sequence is like a special sequence, right? So in this case, we have AN, which is an arithmetic sequence, and we're given these two conditions. We want to find what is the value of A2 minus A1. So remember, like with arithmetic sequences, right? Remember, an arithmetic sequence is defined as a sequence where we have a common difference, where like the difference between consecutive terms is always the same. So if you have A1, the next term is A1 plus D, where D is the common difference. The next one is A1 plus 2D, A1 plus 3D, and so on. So this is equal to A1, A2, A3, A4. Next term would be like A1 plus 4D. That's A5. So notice how like we remember like the general formula, right? AN is equal to A1 plus N minus 1 times D, right? And if you didn't know that, you can just like notice the pattern, right? You have like 2 and 3. So 2 is 1 less than 3. 3 is 1 less than 4. 4 is 1 less than 5. So we can kind of like notice the pattern and create the formula AN is equal to the first term A1 plus the common difference D times N minus 1. And we get something like that. So the idea is, the question asks, what is A2 minus A1? But notice that A2 minus A1, that's just asking for the common difference of the arithmetic sequence. So we have the two equations, like, you know, A1 plus A2 plus A3 plus dot 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 plus A100 is equal to 100. And we have A101 plus A102 plus A103 all the way up to A200 that equals 200. So the idea is we can subtract this equation from that equation, or the other way around. Like we can take the first equation, subtract that from the second equation. And because if we do that, we do the subtraction, we can kind of group these two terms together, right? You get A101 minus A1 plus A102 minus A2 plus dot 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 all the way up to plus A200 minus A100. And on the right side, you would get 100, 200 minus 100, right? So notice that each of these terms, like, notice that like the idea is like for any number, like any two like indices that differ by 100. So in this case, what I mean by that is like if you have A101 versus A1, A102 versus A2, we know that like AK in general. So if we use like some variable like AK, then the next term in the sequence, so let's say you have the number AK, right? Where K is any positive integer, that's going to correspond to the number AK. So if you look at the next term in the sequence, AK plus 1, that's going to equal AK plus D, right? By a common difference. The next term in the sequence, AK plus 2, is going to be AK plus 2D. And so on. Like we're repeating this pattern all the way up to A of like K plus 100. That's going to correspond to the number AK plus 100D by the same pattern. So in general, the idea is if you were to take like this number here, A of K plus 100 minus AK, you would be essentially be taking like AK plus 100D minus AK. So that would give you like 100D. So essentially like what this means in like English terms is like the difference between any two numbers in an arithmetic sequence whose indices differ by 100. So in this case, like K plus 100 versus K, that's always going to equal 100 times the common difference. So now we can use that fact here and notice that like each of these terms in the parentheses, they're like all equal to 100D. Like this is 100D, this is 100D, because all of the indices, like they all differ by 100. So, and since we have like 100 of these parentheses, 100 of these pairs, we would do 100 times 100D. And on the right side, we would get 100. Like, remember, that's what we had in the beginning. So you can cancel out one of the 100s. So you get 100D is 1. So D is 1 over 100, which equals like 0.01, which is the correct answer. And that would be choice C. The idea was, again, we want to find the common difference, A2 minus A1, that asks for the common difference. So we wrote down these two equations. We subtracted the two equations, and we noticed we can like group the subtractions by like pairs, right? In group A101 minus A1, A102 minus A2, A103 minus A3, all the way up to A200 minus A100. And we found that the difference of any two numbers in an arithmetic sequence whose indices, and when I say indices, like I should clarify, I'm just saying like if I have A sub I or something, the index of A sub I, I'm just referring to the number I in the subscript, then the difference between any two numbers in the arithmetic sequence whose indices differ by 100 is equal to 100 times the common difference. And then we found that there were 100 of these pairs. So we did 100 times 100D, and that equal 100. And from there we solved, and we got like D is like 0.01.